Okay, so this is the start of trigonometry. The first thing that we're going to learn in trigonometry is about the three primary ratios and using the special triangles to be able to find exact values. This is really important moving forward using exact values and especially into Math 30-1 if that's the route you plan to go into. So the first triangle we're going to look at is what we call our 45-45 90 triangle. So with this triangle, both of the angles here are 45. This one's 90, adds to 180. The key thing here is we have to know what the other side lengths are. So if I know that the hypotenuse is 1, I can use, and I'm just going to call these other sides x. I know they're going to be the same because both the angles there are the same. So if I use Pythagorean theorem and say x squared plus x squared equals 1 squared, I know here x squared plus x squared would give me 2x squared equals, well, 1 squared is just 1 squared. I'm going to divide both sides by 2. And then I'd take the square root of both sides, which is the same as if I square root the top, the square root of 1 is just 1. So this will be 1 over root 2. So that means that both of these side lengths are 1 over root 2. Okay, one of the other ways that you may see this triangle, so we could see it with the side lengths 1 and 1 over root 2, or I could multiply everything by root 2, and this might be root 2. This side would be 1, and this side would be 1. In that case, like, everything would work the same way. It's just that now we don't have fractions here. So you do need to know this 45 triangle. So this would be 45, this would be 45. I usually think about this one here. So you do need to have this memorized as we are going to use it for exact values moving forward. The other triangle we need to know is what we call our 30, 60, 90 triangle. So to understand the side lengths in this one, I want to imagine that I have an equilateral triangle, all of my side lengths being 2. Okay, and that means that all of these angles here are 60 degrees. Okay, if I want to get to my 35 or 30, 60, 90 triangle, what I'm going to do is cut it in half here. I get a 90 degree, and I've cut this angle in half, so here's 30. Okay, when I look at that, if I've cut this bottom piece in half, that means that I have a length of 1 here and here. So if I look back to my triangle that's here on the right side, that means that this length here would be 1. Now I have 2 side lengths, so I can figure out what the third side length would be using Pythagorean theorem. So using a squared plus b squared equals c squared. So I'm going to substitute in 2 squared equals 1 squared plus a squared. So I'd have a squared, and then I'm going to subtract the 1, and 2 squared is 4. So I'd have a squared equals 3. So a is equal to root 3. So that means this side length here is root 3. So you do have to have this triangle memorized in terms of like where things go. So one of the ways that I look at this is that the 30 degrees is the smallest angle, so it'll be across from the smallest side, which would be 1. You can also remember that the 30 and the root 3 go next to each other, as we'll be drawing this to help us with exact values. So applications of actually using this, so if I wanted to find the exact value of sine of 30 degrees, so I know that sine is opposite over adjacent. So if I look here, 30 degrees, or sorry, sine is opposite over hypotenuse. The 30 degrees is here. My opposite would be 1, and my hypotenuse will be 2. So the exact value of sine of 30 degrees is 1 over 2. Okay, we'll do the same thing with sine of 60. that would be opposite over hypotenuse, which will be root 3 over 2. Okay, and then if I'm looking at 45, I have to go to this triangle up here. Sine of 45 degrees, it doesn't matter which 45 we're going from. I'm going to use 1 over root 2. Okay, and as you would have learned in radicals already, we could rationalize this denominator, and you may see it written as root 2 over 2. Okay, and then cos of 30 degrees. So cosine, I'm looking at 30 degrees. Cos is adjacent over hypotenuse, so that'll be root 3 over 2. Okay, cos of 60 degrees, be adjacent over hypotenuse, that's going to be 1 over 2. And cos of 45 degrees, if I look back up here, so adjacent over hypotenuse, that'll also be 1 over root 2, which would simplify to root 2 over 2. Okay, so if we use our calculator to find the exact values of the following, we're going to take our calculator and when you go into your calculator, you're going to want to make sure that you are in degree mode. So if I want the exact value, I'm going to take sine of 0. Okay, which would be 0. Okay, if I want the exact value of sine at 90, this would be 1. Cos at 0 would also be 1. And cos at 90 would be 0. Okay. So, and if we think back to the coordinate plane, and it's kind of helpful here. If I think about at 0 degrees, 0 degrees is going to be right here. When you learn more about the unit circle in 20-1, this will come into play more, but sine acts like my y value and cos acts like my x. So on this circle, I'm only going to go to where the point here would be at 1 and 0, okay? And that here, this would be 0 and 1, okay? And that this would be -1 and 0, and this would be 0 and -1. So if I look here where sine is 0, so at 0 degrees, sine is 0, sine is my y. At 90 degrees, sine is my y, I'd be at 1. So that's kind of where that's coming from. Okay, and I think I'm good to close that. So it says determine the angle in standard position when the angle 65 is reflected, and this one it says in the x-axis. So the angle that we're talking about to start with is 65 degrees, so meaning that it would be 65 here. If I reflect it over the y-axis, it'll be over here now. Okay, so I need to figure out what angle that is, so I'm going to go and reference from that 180. So this is going to be 180 minus 65, okay, which will be 115 degrees. Okay, so that would be the angle reflected over the y. If I want the angle, if it was reflected over the x-axis, so same angle here, that's 65 degrees, but I reflect it over the x. Okay, so the reference here would be 65. If I want to figure out what that angle is, I'm starting from the x-axis. My reference angle is always in reference to the x. This would be at 360 degrees, so I'm going to go 360 minus 65. and I'll get 295 degrees. And then the last piece, it says, what if it's reflected over the y and then the x? So if I reflect it over the y, so back what I did here and reflected it over the y-axis and then the x-axis, that would put me in quadrant 3. Okay, so then here, in reference to this x-axis, that'd be 180. So to get that angle, I'd have to take 180 plus the 65 because I'm going past that x-axis. So then the angle of rotation here will be 245 degrees. Okay, so this is just using our angles. The next two questions are going to use exact values. So this one says we have a pendulum arm of a metronome is 10 centimeters long. For one particular tempo, the setting results in the arm moving back and forth from a starting position of 30 degrees to 150 degrees. So what that looks like is if I have a position here to position here. I'll draw it from the origin here. Doesn't want to connect where I want it to connect. We'll move this over. Okay. So what this means is that it's starting from a position of 30 degrees here, and then it's going to a rotation of 150, which means if this is at 150 degrees, if I'm thinking about what my reference angle is, I'd have to figure out, okay, what's between the 180 and 150? So this will be a 30-degree reference angle as well. So the question is asking us, what is the horizontal distance it's moving? So it's asking us, what is the length of this blue line? So the question tells us that the hypotenuse here, the length of the metronome arm, is 10 centimeters. Okay. So I need to figure out what this length will be. And I can't do this all at once. I need to break this up into two triangles. So what I'm going to do is think about that this is one triangle here. So if I know this here, this green line is the same as this horizontal line. That's going to be the same length. So I know that this is 30 degrees. 30 degrees is in one of my special triangles. And what I want to find is I'm going to call this x. I want to find x. And in reference to that 30 degrees, this is my adjacent, and I have the hypotenuse. So I know here that if I write that out, cos of 30 degrees is equal to x over 10. Now, cos of 30 degrees, I want this as an exact value. So if I go back up to where I have my special triangle, cos of 30 degrees, cos is root 3 over 2 for 30 degrees. That's what we figured out here. So cos of 30 degrees, the exact value of that is root 3 over 2. Okay, so instead of writing cos of 30, I'm writing root 3 over 2. It's representing the same number. So now I can solve for x. I'm going to multiply both sides by 10. Okay, this will cancel. And then the 10 and the 2, this will become a 5. So that my answer here will be 5 root 3 equals x. However, I'm not completely done. That only represents this one section. And it's following two of those. So I'm going to take 5 root 3 times 2. So the answer is going to be 10 root 3. And this would be in centimeters. So that's where we can use our exact values to be able to solve, or sorry, our special triangles to be able to solve for exact values. Here, you can use the grade 10 idea of being able to solve the primary trig ratio. However, that's going to give you a decimal. And if I'm asking here and it says it wants an exact answer, if you give me a decimal, you're not doing it completely correctly, and you're not going to get full marks. Because you might be able to set up this part, but I'm really looking for you to see and figure out the second part. This might get you maybe 0.5 of a mark. Okay, this says that the tempo is adjusted so that the arm of the metronome swings from 45 degrees to 135 degrees. What is the exact distance of the tip and the arm travels in one beat? So now, same thing, we're gonna set this up. And if I'm going from 45 degrees, I know that that's traveling 45. 135 degrees, the reference angle there is also going to be 45. Okay, this is in reference to the last question as well. So I know that the arm here is going to be 10 centimeters. Okay, so I want to figure out then, okay, how far is it traveling in one beat? I'm looking for the same thing. I'm going to use one triangle. I'm going to solve for the adjacent and then multiply my answer by 2. In this case, though, I'm looking at the 45 degrees, so I am going to use a different triangle. Let's write down our ratio first, though. So I'm going to use cosine of 45 degrees is equal to x over 10, cosine of 45 degrees, and I know we wrote it down here. I just want to show you how we're getting that again. If I'm looking 45 degrees, cosine is adjacent over hypotenuse, so that'll be 1 over root 2. Equals x over 10. And then we have to multiply both sides by 10. So this will be 10 over root 2 equals x. I'm going to have 2 of those because this is only half of this. I'm going to rationalize the denominator first and multiply by root 2. So this will be 10 root 2 over 2, which will simplify into 5 root 2. And then I know that that's just the simplified length here. I need 2 of those. So 5 root 2 times 2 is equal to 10 root 2 centimeters. Will be the entire length that it's traveling horizontally.